In this task, we want to transfer this Wheatstone bridge circuit into a practical current source, so into the Norton's equivalent. What we already know from lecture about this circuit is the open loop voltage. We calculated this voltage here in the lecture, so have a look there. The result is this. Okay, for our practical source, we also need the inner resistance of our circuit. And that is the resistance from clamp to clamp, and all the sources are deactivated. That means our ideal voltage source becomes a short circuit. Okay, and now it's a bit difficult to see the total resistance of that circuit, so let's draw it another way. Let's start at clamp A. Okay, if we walk into our circuit from clamp A, we come into a knot, and there the circuit splits, and we can draw it like this. On the upper side we have the resistor R1, and on the lower side the resistor R2. Okay, if we walk through R1 and go to the right, we see that we come to resistor R3. And if we walk through R2 and go to the right, we see resistor R4. Okay, but that's not all. Between these resistors R1 and R3 and R2 and R4, there are also knots, and we have a short circuit between them. Okay, let's move back to our resistors R3 and R4. We see that the connections meet in the middle, and there is our clamp B. Okay, and now it should be possible to calculate the total resistance. And I know that students in the beginning have often difficulties with such a circuit, and therefore I will redraw it a bit. Have a look to the middle of the circuit. Everything is connected there, and therefore I could also draw it like this. And now you obviously see that we have a parallel connection of R1 and R2 in series to the parallel connection of R3 and R4. Okay, and that means we already know the values for a practical voltage source. It's our open loop voltage and our inner resistance. But we want to find the practical current source. And that last step is really easy because we can transform our sources. The inner resistor will be the same, and our short circuit current of that current source there can be calculated with Ohm's law. And that's all.